Today we are doing 12.1 probability distributions.
Okay, so we're first going to talk about a frequency table. So a frequency table is a list of the outcomes in a sample space and the number of times each outcome occurs. So let's take a look at this example here. We're going to make a frequency table by looking at the different types of triangles. So we have an equilateral triangle where all the sides are congruent, isosceles triangle, 2 of the sides are congruent, and a scalene triangle where no sides are congruent. So we're going to fill out this table here. So we have an equilateral triangle. We're just going to count how many of these triangles are equilateral. We're just counting the number. 1, 2, 3, 4, 5, 6. So 6 of the triangles are equilateral. Isosceles, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them are isosceles. And scalene, we'll count those. 1, 2, 3, 4, 5, 6, 7, 8 of them are scalene. So we have 8 that are scalene. And then we're going to just add up the total amount of triangles. We are adding those up and we have 25 triangles altogether. Okay, so that's our frequency table that we just made. Notice that I just added up the amount of triangles. We didn't find the probability or anything like that, just adding up how many we have. So moving on here, if we take a look at the cumulative probability, that's the probability over a continuous range of events. And we're taking a look at this frequency table here where it's talking about the contact between children and elderly who live alone. So we want to find the probability that an elderly person living alone will have contact with his or her children more than once a week. So if we take a look at this table here, we have less than 1 time per week, that's not going to count. 1 time per week, that won't count. 2 to 6 times per week, this one will count. And 7 times per week, that one will also count. So we're going to just take 276 plus 680 and we're going to divide that by our total of 1391. So when we add those up, we'll get 956 divided by 1391. We can go ahead and divide those and we'll get a decimal of 0.687 about. And writing that as a percentage, we get 68.7%. Okay. All right, so moving on, we're talking about probability distribution now. So a function that gives the probability of each event in a sample space. So we're going to take a look at rolling 2 number cubes. Okay, so if we have 2 number cubes and we want to find the probability distribution for the sum of the numbers, well, if we want to look at the sum, the lowest sum that we can get for 2 number cubes is I can roll a 1 on the first and a 1 on the second. So the sum of that, 1 plus 1, is a 2. That's the lowest sum that you can get. Then we can get a 3. We can roll a 1 and a 2. That would be a sum of 3. The highest sum that we can get is, our highest numbers are a 6 and a 6. So the sum of that would be a 12. And that's your highest sum here. So we're going all the way up to 12. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and our highest sum is 12. Okay, so we want to talk about the frequency now, so meaning how many times it actually comes up. So if we're talking about a sum of 2, we only can have this come up once. So when we get a 1 and a 1, that will give us a sum of 2, and that's the only time it will come up. So the frequency is just 1. If we have a sum of 3, we can roll a 1 and a 2, and then these can actually switch. We can roll a 2 and then a 1 on that, and it will have a sum of 3. So there's 2 different times. If we roll, if we want a sum of 4, we can roll a 1 and a 3 and a 1, and a 2 and a 2. So that's 3 different times. This will be 4 different, 5 different. If we want a 7, we can roll a 1 and a 6, 1 and a 6, a 6 and a 1. We can roll a 5 and a 2 and a 5, a 3 and a 4 and a 3. So that's 6 times for rolling a sum of 7. And now we're going to actually go back down, because we just said for the sum of 12, there's only 1 possibility. For 11, there's 2. This one is 3, 4, and 5. So if we actually want to take a look at the probability now, we know that the possibilities are, there's a total of 36 possibilities, and that's because there's 6 possibilities for the first number cube, there's 6 for the second, 6 times 6 is 36. So I'm just going to take the frequency, so the frequency for a sum of 2 is 1 out of 36 then. The sum of a 3, there's 2 times where we can get a sum of 3, so the probability will be 2 out of 36. This one will be 3 out of 36, and so on. And so the highest one that we're going to get is 6 out of 36, and then we're going to go back down after. Okay, so if we wanted to draw a graph in here for this, I can make a graph here. Here's my lovely graph. At the bottom here, I can say what the sum would be. So I can have a sum of 2, 3, 4, 5, and then it would go all the way up to 12, right? Okay, because that's the highest one. Over here, I can say the probability. So the probability over here, so the highest one is going up to 6 over 36. So I can say 2 over 36, and 4 over 36, and 6 over 36. Yours should be a little bit neater than mine, obviously, but just to sketch this out. So the probability of having a sum of 2, we said, is 1 out of 36. So draw this in here, a little bar graph. The sum of a 3 would be 2 out of 36. So we'll just draw that in here. Again, sorry for my messy graphs. Okay, there we go. Sum of a 4, that comes up 3 times, so that is 3 out of 36. Looks like my graph's getting a little messier. But this is going to go up, and then it's going to go back down. And that's how you would make it into a graph. Okay, finally, we are going to be talking about using a probability distribution, and we're going to use the probabilities to assign numbers to each event in the sample space. So, for example, if we have a probability of 0.15, then what that's doing is it should be assigning 15 out of 100 numbers to that event. So here's what we have here. It says, at a certain store, the number of customers C who arrive at the checkout counter at each minute varies according to the distribution below. So what this is saying is it's saying if there's 0 people, the probability of having 0 people at the register is 15%, or 0.15. Having 1 person would be 0.24, or 24%, and so on. This is the number of customers C, and this is a probability. So what we're going to do here is we're going to assign numbers from 1 to 100 to the events. So we're going to write this in here. So the probability of having 0 customers would be 0.15. And I'm just taking this from the chart above. The probability of having 1 customer is 0.24. Probability of 2 customers is 0.28. 0.17. 0.09, 0.05, and finally 0.02. Okay, so now what we're going to do is we're going to look at the cumulative probability. So for this, there's actually nothing to add up, so we just have 0.15. And now we're going to assign numbers. So if it's 0.15, if we're assigning 100 numbers here, then 0.15 is the same as saying that we're going to assign 15 out of 100 numbers. So let's assign the numbers 1 to 15. So then the cumulative probability is we're going to just add these up. So 0.15 plus 0.24 is going to give me 0.39. And then this is going to include 24 numbers in the assigned numbers. So I'm going to have 16 to 39 here. Again, the cumulative probability, we're going to add 0.39 plus 0.28. When I add that up, that will be 0.67. So I'm going to start from the next integer, which is 40, and I'm going to go up to 67 here. So that ending cumulative probability is helping me assign the numbers. So now we're going to add 0.17 to 0.67, 0.84. So this is going to be going from 68 to 84. Add 0.09 to 0.84, I get 0.93. So this will be from 85 to 93. Add 0.05, 0.98. So this is going to be from 94 to 98. And then finally add 0.02, I get a 1. And this will be 99 to 100. Okay, so now what we're going to do is we're going to actually conduct the simulation. We're going to model a 10-minute period by generating 10 random numbers from 1 to 100. So what we're going to do here is we're just going to Google a random number generator. So random number generator here, see what comes up with that. And let's see, you can use any of these here. Oh, apparently not that one. Let's see, might work better in my other account. So let's see here. Random number generator. Here we go. Okay, so we're going to assign numbers now, and what we're going to do is we're assigning from 1 to 100. So that's going to, we're going to assign a lower limit of 1, and then an upper limit of 100, and then we're going to see what we come up with. So let's make this a little bit smaller here, and then we could just write the numbers in as we go. Alright, so we're going to enter this in. We'll press enter. We get 51. $67. 68. These are just all random numbers. 73, 46. 7, 100. 43, 88. See how many we got here. 2, 4, 6, 8, 9. One more. And 43. Alright, so we're going to look at... Now what we're going to do is we're going to see where they fell. So we have our 10 numbers. And we're going to see where they fall between. So 51, we're going to look here. 51 is going to fall in this range here. So I'm just going to make a little tally mark. It's in the range of having 2 customers. 67 is also in that range, so another tally mark there. 68 is right here. 73 is in here. 46 is in this one. 7, 0 customers. 100 is in this range. 43 right here, 88 is right here, and 43. Okay, so if we look here, the more numbers that we pick, the more accurate that it will actually be. But if we take a look at some of these, this one right here is telling us that we actually had 2 out of the 10, which is 0.2 or 20%, fell within this range. And if we look at the probability, this came out with 0.17, which is really close to 20%. But if we use more numbers, if we kept going with our random number generator, we would have gotten something even more accurate. Same with this one. This is 1 out of 10, and 1 out of 10 is 10%, which is pretty close to 9%. And that is interpreting the type of simulation that we just did here. And that will conclude 12.1, probability distribution. Thanks for listening.